Direct, analytical tone. Look around any modern city, and you are standing in a dense, continuous field of radio frequencies. This reliance on the electromagnetic spectrum is the core vulnerability exploited by modern signals intelligence. Signals intelligence, or SIGINT, is the collection of intelligence through the interception of electronic signals and communications. Even if a message is perfectly encrypted, the act of transmitting it can be detected. The mere presence of a radio frequency emission betrays the sender. Adversaries use traffic analysis and triangulation to pinpoint the physical location of an operative the moment a signal hits the air. In highly contested, zero-trust environments, mathematics cannot protect you. Traditional cryptography fails if the transmission medium itself is compromised by the enemy. To achieve operational security today, an intelligence framework must completely bypass the RF spectrum. It has to operate entirely within the physical and optical domains. This requirement is the foundation of a recently filed patent portfolio authored by R.J. Aguiar. These 15 applications function as a comprehensive, multi-layered blueprint for modern information warfare. Aguiar defines this system as the architecture of control. It is designed to secure data logistics at the ground level, while systematically denying adversaries the computing power required to process that data. This diagram shows the system's structural framework. It operates across a layered stack, beginning with physical tradecraft, moving through optical air gaps, ascending to orbital surveillance, and terminating at strict legal choke points. We will deconstruct this architecture layer by layer. We will examine how tactical engineering and strategic patent law are fusing to dictate the future of global power. The first tactical bypass targets location tracking. The front line of covert data transfer is often a mundane public setting, like a retail store aisle. Direct agent-to-agent data transfers carry an inherent risk. Both operatives must occupy the same physical space at the exact same time. This creates a highly observable temporal link for counter-surveillance teams. Aguiar's solution utilizes low-power electronic relays. These small, static devices are intentionally hidden within the hollow structural elements of common public infrastructure. This technical diagram shows the specific mechanics of concealment. A transceiver is embedded directly inside retail gondola shelving, exploiting void spaces that are publicly accessible but rarely subject to inspection. This diagram illustrates the operational workflow. The first operative approaches the location, wirelessly uploads the data packet to the concealed device, and leaves the area. The second operative arrives much later to retrieve the data. The two parties never cross paths. By decoupling the sender and receiver in time, the communication becomes completely asynchronous. This permanently severs the physical link required for traffic analysis and tracking. The second tactical bypass addresses air-gapped networks. An air-gapped system is a highly secure computer that is physically isolated from all unsecured networks and internet connections to prevent data exfiltration. To extract data without emitting traceable radio frequencies, the portfolio details an optical side-channel attack. This is an entirely software-based method to bleed information out of an isolated machine. The mechanism relies on malware that subtly modulates the brightness or color of specific pixels on the target's monitor. It fluctuates at high frequencies to encode binary data into light. This flickering is entirely invisible to the human eye. However, it is easily captured and decoded by a disguised optical sensor placed nearby in the room. This technique turns any standard display monitor into a covert one-way optical transmitter. It bypasses conventional network security using basic light physics. The third tactical bypass solves the problem of long-distance communication. The objective is to transmit critical status updates to a remote command center across the globe without generating a single radio wave. The solution is macro-scale visual steganography. Visual steganography is the practice of concealing a message or data within a non-secret image. Here, it utilizes the existing imaging systems of non-cooperative surveillance or Earth observation satellites. This technical diagram shows the system relies on physically arranging large, movable objects within a designated signaling area, like an industrial equipment yard. These objects must use distinct, trademark-protected colors, such as caterpillar yellow. Because these exact paint mixtures are statistically rare in nature, computer vision algorithms can easily filter out environmental noise to identify the target. The encoding process is multidimensional. Operatives use the presence, the spatial combination, and specifically the rotational orientation of asymmetrical vehicles to represent different message states. The orbiting satellite passively captures this visual arrangement during its scheduled pass over the coordinates. It bypasses ground-based electronic interception entirely. By weaponizing the physical geometry of everyday objects against orbital imaging schedules, operatives create an invisible, broadcast-only communication channel. It produces zero electronic emissions for SIGINT to detect. Moving from the tactical collection of data, we reach the macro-level challenge of processing it. Specifically, we have to look at the massive computational demands of the coming quantum era. There is a critical hardware bottleneck currently preventing quantum computers from networking together effectively. Traditional fiber optic cables transmit data serially, meaning they send information one bit at a time. AGIA introduces the CVBNI interconnect as the solution. The CVBNI is a high-bandwidth, low-latency optical data cable that completely abandons serial transmission. Instead of sending serial ones and zeros, the CVBNI uses a microdisplay and image sensor to transmit data simultaneously as frames of light. By treating every pixel as a discrete channel, it achieves the terabit capabilities necessary for classically unmanageable datasets. The entity that controls the patents to this parallel optical interconnect controls the physical nervous system of future quantum computing clusters. Adversaries with extensive histories of intellectual property theft and industrial espionage require quantum networking capabilities to maintain global parity. To counter this, the architecture utilizes restrictive licensing as a tool of geopolitical enforcement. A patent holder possesses the legal right to dictate exactly who their commercial licensees are allowed to do business with. The strategy applies a strict clean hands contractual clause. To legally use the CVBNI technology, a Western tech company must certify they have zero active partnerships, joint ventures, or supply chain dependencies with targeted foreign entities. Adversaries facing this blockade often attempt to litigate, claiming the restriction is an illegal restraint of trade or constitutes patent misuse. To defeat this counter-argument, the inventor utilizes a double-tag defense strategy. This pairs commercial patent restrictions with high-level federal lobbying. The goal is to successfully lobby the federal government to designate the adversary as a foreign terrorist organization. An FTO designation legally prohibits American entities from providing material support to that group. This aligns the private contract with federal law, immediately rendering any patent misuse claim void. This creates an inescapable dilemma for major tech firms. They must choose between maintaining business ties with state-sponsored intelligence networks or securing access to the interconnect required for quantum computing. They cannot do both. This structural diagram shows the complete cycle. The system secures data extraction at the tactical edge, bypasses RF interception entirely, and then denies raw computational power to adversaries at the strategic core. In this era, intellectual property and patents function as explicitly weaponized instruments of sovereign strategy. They are active tools of national power, rather than passive commercial monopolies. Defeating an adversary does not rely on intercepting their signals. It relies on legally and physically controlling the architecture they need to survive. True power in global conflict is found in engineering the physical and legal topology of the hardware itself.